Hey everybody, it's Mr. Carr again. Today we're going to be talking about 5-6. Part of 5-6 is we're going to use synthetic division in order to evaluate polynomial functions. Okay, and so this is what it looks like. Let's say we're trying to find f of 2 given this polynomial. Okay, so the remainder theorem tells us this. If a polynomial is divided by x minus c or x equals c for synthetic division, the remainder is the same as evaluating the function at c, or basically finding the remainder is going to be the output of f of c. This is what it looks like. I'm going to take 2, put in my box. I'm going to set up my synthetic division. So I got 2. We're going to skip x to the third. So we'll put 0, -5, 8, and -7. So that's x to the fourth, x to the third, x squared, x to the first, and then x to the 0. Okay, so we're going to go through and run through our synthetic division now. We'll drop the 2. 2 times 2 gives me 4. Put it right there. 4 plus 4, 0 plus 4 gives me 4. Then I'll take 2 times 4 is going to give me 8. -5 plus 8 is 3. And then 2 times 3 is going to give me 6. Put that together, we get 14. And then 2 times 14 is 28. -7 is 21. So according to the remainder theorem, if I try to evaluate f of 2, that's going to equal to 21. Just for comparison's sake, let's go ahead and see that. So f of 2 is equal to 2 times 2 to the fourth minus 5 times 2 squared plus 8 times 2 minus 7. Okay, so I'll just do it step by step so we can see each thing that happens. So 2 to the fourth is going to give me 16. Times 2 is 32. 2 squared is 4, times 5 is 20. 8 times 2 is 16, and then -7. Okay, so f of 2 here, I can take 32 minus 20 is going to give me 12 plus 16 minus 7. And I can put those together as 12 and 16 is 28 minus 7, and that gives me 21 in the end. Okay, and that's our remainder theorem. So that's the idea there. Determine whether x minus 3 is a factor of this polynomial, then find the remaining factors of the polynomial. So here's the idea. If this is a factor, we are going to try to divide that into this. So that means we are going to take, let's do synthetic division here. Okay, so we're going to do it as x minus 3. It's going to become a positive 3 in that corner there. X to the third, we got 1 x to the third plus 4x squared minus 15x minus 18. Okay, so if it is a factor, okay, then according to synthetic division, our remainder should come out as 0. That's the idea. So that is if x minus 3 is a factor of this. So we would have 0 for the remainder is the idea. Okay, so let's run through and see if we do get 0 here. So drop the 1. 3 times 1 is 3. Combine those to get 7. 3 times 7 is 21. Combine those to get 6. 3 times 6 is 18. Combine 4 is 0. So we just confirmed that yes, x minus 3 is a factor. Okay, so that means when I look at what's left, remember this was x to the third, x squared, x to the first, and x to the 0. This is going to be x squared, x to the first, x to the 0. So I'm going to have, if I were to factor out an x minus 3, this is the result. X minus 3 times x squared plus 7x plus 6. Okay, I'm taking my factor, putting in front. The remaining coefficients here is my new trinomial. From there, to get it any further in a factor form, I'm going to double check. Can I factor this any further? Okay, so it says factor the remaining depressed polynomial. And that's what this is. It's my depressed polynomial. We factor out the x minus 3, that's what we're going to call it. So double check. Can I factor x squared plus 7x plus 6? So I'm looking for numbers that multiply to 6 and add to 7. I get plus 6 and plus 1. So that is my fully factored form of this right here. This is going to be the equivalent of this one. Okay, so that's our two main parts of today. So a quick reminder, this is the remainder theorem. We can use our synthetic division or any polynomial division. And basically, we evaluate any value we want here, and the remainder is the output of that. The other part of it is understanding that if we get that zero remainder, that means that whatever we divided by, okay, is a factor of that polynomial. So we can then factor that out, and then whatever else is left, we can keep factoring if we can. All right, that's it for this lesson. Take care.